What if I told you a teeny neural network just have the 7 million parameters can outperform models like Google Gemini 2.5 Pro, Claude, and even the DeepSeek R1 on tough reasoning tasks like the Sudoku Sudoku, as well as the maze problem like rate in match as well as the ARCAGI. So, welcome to the world of Dini recursive models or the TRM. So, recently, the Samsung Sale Montreal is actually publishing here a paper called Less is More Recursive Reasoning with Tini Network. I am Mr. Chandu and I am super excited to creating this video. So, let's start. So if I see the paper, so in the paper you can see a line with only 7 minimal parameters. TRM obtained 45% test accuracy on ARCAGI1 and 8% of ARCAGI2, higher than the most LLMs. Examples, the DeepSeek R1 O3 Mini, Google Gemini 2.5 Pro. See which one is the groundbreaking thing, right? So you can also see what architectures having the cross entropy loss, the reverse embedding, as well as you can see here a layer where you have the at and norms, the MLP multi-layer perceptrons, at and norms, also called the layer normalizations, and the self-attention block. And you can see some recursive formula actually. So if I just going to simplify things from the paper, it basically taking here an input questions, and after that we have the two more variables. One is the initialized answers, another one is latent state object. And then we have the T network, which can have the two layers. So one layer is basically consisting of the linear or the attention layer, and the sui glue activation functions and layer normalizations is basically using here the RS norms. And then it will basically updating here the latent jet using a recursive n times. So if you know that how can you basically solving any problems in the Sudoku or rate in match, it's basically a backtracking problem in the DS. So in the case of DS, we basically recursively solve this problem by finding here all the possible path, that how can a rat go from one side to another side or one box to another box with the shortest paths like that. So update the answer y and once per outer loop and repeat the t time progressively better than one. So no problem, I understand this thing very well, but the problem is here, we cannot use it here the large language model. Now why the large language model is failed and why these teeny neural network is coming on here. Okay, so if I see this one, the questions, why large language model is basically failed, because we can using the large language model by for solving here this kind of precise things, I mean this kind of tasks, but we can't. Why? See, large language model or LLMs like GPT, I mean chat GPT or Google Gemini are powerful, we know that, but they often failed at puzzle, you can see puzzles that require precise step by step reasoning. This is the main important part. You can taking here and red pen. So see, require here the precise step by step reasoning. That's the main thing on here. Require here the precise step by step reasonings. Why? Because a single wrong token in a chain of thought can ruin your entire answers. Because this is a puzzle problem, right? Now, what is the chain of thought? You already know that. What is the COT in the large language model? Okay, so it's nothing but one kind of technique. How do you basically give the examples? Now, the next one, enter the recursive reasoning. Why we need the recursive reasoning? See, instead of thinking once, so what if a model could rethink its own answer repeatedly, like a human reversing mistake? If I see the large language model, it basically try to fit the data and try to predict the next token for the once a time. Now, what if we think the model can rethink it and its own answer repeatedly, like we basically do in the human? Let's say I'm trying to solving here a DSA problem, or let's say I revise, I solve all of the problem about the DSA. Now I need to revise for my interview. So what I can do, I revise them to find my mistakes, So this is how that is happening in the case of recursive reasonings. So that's what recursive reasoning does. So the earlier model is called the hierarchical reasoning model, also called the HRM. This is nothing but an earlier model before the TRMs. So it basically used here two small network that resonate at different frequency like two parts of a brain working together. So in this video, you basically break through this paper that what actually they're written down. I just explain all of the things on here, why we need it, right? Now, how the HRM basically worked. So HRM improved its answer through multiple reasoning cycle, each time refining its internal thought. See, internal thought is refining them recursively. It used here a deep supervision. See, the main important one, it using here deep supervisions, meaning it was trained to improve the answer step by step and analyze the competition time. See, and the adaptive competition time, you can see adaptive competition time, also called the ACT, to decide when to stop thinking. See, if I see this flow third, so why actually show you? See, repeat the T times, progressively better the Y. Now, when you need to stop, when you need to stop. So we need to stop when the adaptive competition type is decided to stop thinking, right? Main theme, it's coming up. So problem with HRM. So what is the problem with the HRM and why you need to using here the TRM? So if I see the parameter size of the HRM, it's nothing but the 27 billion, sorry, millions. So it's quite big. Also have the two layers. But HRM have some few issues. If you see that, it relies on complex math like implicit function theorem. You can just go on the Google and search for that. What are the implicit functions theorems? It needed two network, more parameter. You can see it needed two network and more parameters. Also, when we basically have the two network, so it also record to forward passes, to record forward passes for the each time in the case of training, and it also doubling the competitions. So when you basically creating here any kind of gradient, so you need to creating here the forward pass, right? So in case of that, when you basically created here two neural network, so you need to also implement here two forward pass in a one single functions. See how big, and it will doubling the competitions. The competition power is quite high. Also, it using the biological metaphor about the brain frequency. Fascinating, but not a practical. It's fascinating, not a practical yet. That's the main problem in the case of the HRM. Now let's see the back throw, the tiny recursive model, also called the TRM. Then comes the tiny recursive model, also called the TRM. A single two-layer network has the 7 million parameters that thinks recursively to refine its own answers. It's so efficient that it beat the HRM and even the large language model on key reasoning benchmark. The key reasoning of the benchmark. Now let's see the paper first. Then we see that how the TRM actually work. As well, let's see the Hugging Face repo of the HRM. I mean TRM. They discuss about the HRM. I'll go on here right now. So this is the actual paper that you can see. So if I go down, you can see the structure and goal, how they basically a recursion of two different frequencies, as well as they also given the code in the case of PyTorch. So they also discuss about the what is the adaptive competition time ACT. You can also see on here. You can just read the paper. I just back to this paper. Okay. So you can see HRMs, the accuracy, the depth, the number of parameters. You can see 27 million parameters it have, and you can see benchmark maybe. In the result, you can see the DeepSeek R1, the Claude 3.78K, O3 mini high. So in the case of the parameters, and you can also read about it. Okay. So if I go on the Hugging Face, that you can see less is more recursive reasoning with TD network. You can see that one line. Hierarchical reasoning model HRM is a novel approach using two small neural network recursive at different frequency. This biologically inspired method beat the large language model LLMs on hard puzzles such as Sudoku, Maze, and ARC-AGI. While training a small model 27 million parameters on a small data around 1000 example, HRM holds a great promise for solving the hard problem with a small network. But it is not yet well understood and maybe the suboptimal. We proposed here a tiny recursive model and much simpler recursive reasoning, a process that achieve the significant, the higher generations than HRM. And they also discuss about the accuracy. So this is a GitHub repository. I will attach this GitHub repository in the YouTube descriptions. Okay. Now let's go on here again. So now let's see what are okay, how the TRM actually work. So TRM takes basically three things. We already discussed about that. The questions, it's basically X. The current answer, it's a Y, and a latent reasoning state called the jet. We already see it before. Okay. So then it refine the jet several times and update the Y over and over. It basically updating the current results and try to recursively update it and try to make it optimal. So until it improves, each recursion step help it correct all their mistakes. Yes, model can do the mistake because they are not human. Even the human also do the mistake. How you basically in a 3 or 4 year when you start speaking, we do so many mistakes. So same thing in the case of the TRM, it's also do the mistakes and recursively to try to overcome this thing and try to improve it. Now, why it is better? Because see, TRM remove everything unnecessary. One, no complex theorem. It don't need any kind of complex theorem. Okay. No two network setup. You don't need to set up the two network. No extra forward pass. You don't need to creating here any extra forward pass. Just one simple recursive network. And the result is the higher accuracy, lower overfitting problem. You know that what is overfitting actually, and faster training. Okay, and the faster training. Overfitting means it will actually basically train on the trained data well, but unable to predict the texting data or the unseen data. Now, if I see the features in a table, so network, it just has the two network, and TRM had just one single network. You can see just one simple recursive network. And params is basically the 27 million parameters and the 7 million parameters. And accuracy, the Sudoku 55%, and you can see here 87% in the case of TRMs. And accuracy in the case of the AGI, it's 5% and is basically 8%. Now let's look at the benchmark. So in the Sudoku Extreme, you can see TRM 87%, HRM is 54%, the Mage Herd is TRM 85%, and HRM is basically 74%, quite less. TRM is 45% and HRM is 40%, and ARC AGI is 8% and HRM is 5%. So there's are massive gains using just 0.1% of the parameters of the top of the large language models. Okay. Now why less is basically more. The key inside smaller model is basically generalized better how you train it recursively. So instead of memorizing the data, because that is basically done by the large language model, that's why it's quite big. It's the 10 GB, it's the 15 GB, it's the 20 GB, even though many can be 100 GB as well. But they learn to think iteratively, just like a human correcting themselves in the case of recursive thing. But LLM is basically memorizing these things, okay, and it try to predict the next word. Now, what is my final thought actually? So TRM shows that we don't always need billion parameters monsters. Yes, we don't need it. With the right recursive logic, a teeny brain can think big. So this could be redefined how we basically design here the AI. So smaller, faster, and smaller so that everyone can easily use it. Okay. So this is basically a breakthrough down of the papers called less is more in a simple manner way. So recursive reasoning with the teeny network. That's it from my sides. So I hope you enjoyed this full video. So I'll suggest you to also watch my multiverse of 100 plus data science project series. So here we basically uploaded here at already 84 plus projects. So you can also follow this out and you can share with your friends as well. So thank you and bye bye. Namaste.